right, so the first one, it says the measure of PQT is 51.5. Is that the top portion, bottom portion, or the entire angle? The top portion. So we have out a sheet of paper. Do you have a pass? Yes, ma'am. You just put it on your desk. We have a sheet of paper, and we're drawing these and answering them. Okay. So we have 51.5. Is TQR the bottom portion or the overall angle? The bottom portion. All right, so then it says find the measure of PQR, which is the outer. So what do I do in order to find the measure of the outer? I'm going to add them together. So 51.5 plus 48, what do I get? 99.5. So your answer would look like the measure of angle PQR is equal to 99.5. Yes, ma'am. I won't take off if you don't. All right, the next one we have PQR is 113. Is this the top portion, bottom portion, or the whole angle? The whole angle. TQR is 30.25. Is that the top portion or the bottom? That's the bottom, TQR. All right, so it asks find PQT, which is the top. So what are we going to do in order to find that? We're going to subtract. So 113 minus 30.25. What do we get? 82.75. So the measure of angle PQT, 0.75. So someone asked me why I didn't round to the tenth like we've normally been doing. What did the problem round to? It's not the tenths, it'd be the hundredths. So they kind of set the standard. So in order for us to have an exact answer, round the way they did. Okay? You're going to draw another two of them. Okay, and we're going to answer them. Changing screens. Go ahead and draw this. All right, so we're going to begin number 3. So, it says in the diagram, the measure of BDA is 104. Find the measure of ADC. Are these angles equal? No. What would it say in the directions if they were? Bisect. It doesn't say that. What would it have in the picture if they were? Yeah, the little arcs. Okay, here's also another clue. If you don't like cake, then don't even answer, because you're just not in the realm of normal. So let's say we had a nice Publix cake. You know what I'm talking about? Okay, all right, it's before lunch, y'all. So let's say you were offered this slice, or you were offered this slice. Okay, which one is there a difference? Which one is bigger? Yeah, CDA, the purple. Okay, that's the slice that I'd be asking for. Okay, so they're not equal. So then we have to go with the inner plus the inner equals the outer. What is the measure of the outer angle? 104. So we're going to take the two inner pieces. What's the measure of BDC? 6x plus 5. I kind of wrote over the arrow. There's an arrow here. So we'd add 6x plus 5. And then what would I write next? Plus 2x plus 59. Good. As it is this an equation? No. What is it missing? An equal sign. So you can't solve it if there's no equal sign. You're not solving for anything. You're just wasting your time. So there has to be an equal. And it will equal the outer angle, which is 104. Okay? Once you've hit here, this is now just algebra. That's all you're doing. So everything is on the same side. So you just do what it says. It says 6x plus 2x. What is 6x plus 2x? 8x. Plus 5 plus 59. 64, yeah. and it equals 104. What would my next step be? Subtract 64. So 8x equals 40. Divide by 8, and what does x equal? 5. So I don't circle that because I haven't answered the question. What does it want me to find the measure of? ADC. So ADC was the 2x plus 59. So that's where we're going to plug in our x. What's 2 times 5? 10. Plus 59 is 69. So you're going to say the measure of angle ADC is 69 degrees. I'll give you a second to finish drawing the second problem. The second, are the two angles equal? Does it tell me that they are? No. So in the directions, I don't see the word bisect. Does it have arcs that tell me that they're equal? No. What does this little box mean? It means it's a 90-degree angle. So they're not equal. They're going to add up and equal 90 degrees. So starting with the first angle, we'll have 9x minus 31. Add it to the other inner angle, which is 6x, minus 14. And they will equal 90. From here, we just use our algebra. We have 6x and 9x, which makes 15x. We have minus 31 minus 14, which is negative 45. Good. And that equals 90. My next step, add 45 to both sides. What is 90 plus 45? And then my last step, divide by 15. Did you already answer this one? No. So you should be writing with us. So this would be counted as incomplete on your notebook check because you're not actually answering with us. Like all of this is the work. You can't just look at it and have the answer. That's not helpful to you. Sorry, what did we say? 9? Good. So where do we need to plug it in? ADC. So 6 times 9 minus 14. 6 times 9 is? 54. Minus 14 is? 40. So you would say the measure of angle ADC equals 40 degrees. What do you mean?
Like,
you can. If it were a test, I would recommend it. But you're doing it with me, and I know the answer. But a way to check it, you can plug it in here as well at the 9x minus 31. What should this other angle be if the one we just solved for was 40? This one should be 50 because 50 plus 40 is 90. So it's a good way to check yourself. We will finish the review on Monday, so you can go ahead and put this away. Take out a red pen and your homework. So adjacent angles, here we are. Adjacent angles, two angles that share a common vertex and side, but have no common interior points. That is the first term at the top of your page. So adjacent, two angles that share a common vertex and side, but have no common interior points. Two angles that share a common vertex and side, but have no common interior points. And I will explain it. So two angles that share a common vertex and side, but have no common interior points. So in an example, what are the sides of my room called? Walls. Okay. This side, or this wall, I share this wall with Miss Dix, right? The Algebra 2 teacher. So we have an adjacent wall. We are adjacent to each other. What do I share with on this wall? The cafeteria. So I am adjacent with the cafeteria because we share this literal wall. From this corner to that corner, we share this piece of the wall. That make sense? Who do I share it with on that side? Miss Belk. So Miss Belk and I are adjacent to each other because we share that literal wall. What do I share with on this side? The hallway. I don't share with Miss Hat. Why not? She's across the hallway. She's not on the other side of my wall. That makes sense? So what you're going to write, you're going to highlight. You're going to highlight this. Okay? Adjacent in layman's terms means angles that share a wall. And this is the wall they share that you're going to highlight, and then you're going to label. We'll talk about the other picture you have in a second. So adjacent angles, they share a wall. So you should have highlighted that and then written share a wall. Yes, sir. I could have said something sassy, but I'm recording. All right, so the first one, because it has a common side, okay, so that wall, and they have a common vertex, which is B, this is adjacent. And the other two are not adjacent. Okay, so you just want to label adjacent and not adjacent. So the first set, adjacent, second set, not adjacent. How many vertices are in the second picture? 2. What is a vertex? It's the corner. So there's 2 vertices, whereas in the first picture there's 1. And then they, again, don't share a wall. They all have 2 individual rays. All right? So then you have one other picture. It's the first one under adjacent, and it looks kind of like this, yes? Okay. So here's what you're going to do with your highlighter. This angle and this angle are adjacent because they share this wall. If you swap highlighters, this angle and this angle are adjacent because they share this wall. This angle and this angle are adjacent because they share this wall. And then this angle and this angle are adjacent because they share this wall. So when they share a wall, they're literally side by side like this. Okay? So how many set of adjacent angles were there in this picture? There's 4 sets. Okay? So whenever 2 angles are right next to each other, they are adjacent to each other. You will see this word the rest of geometry. Adjacent. You'll see it in trigonometry. Hopefully you've heard of it before. Have you heard of SOHCAHTOA before? Yes. SOHCAHTOA? Sine, cosine, and tangent. You've heard of it. Well, the A stands for adjacent. All right, so we're going to move on to complementary. So you're going to write my definition instead of the books. You ready? Complementary angles. 2 angles. Oops, sorry, pause. A great, right before lunch. A great example of adjacent angles would be these 2 slices of pizza. They are adjacent. So whenever you have unsliced pizza, the 2 next to each other are adjacent. They share 1 vertex at the center, but adjacent. Okay? Sorry. So complementary. Complementary are 2 angles that add up to 90. So I'd write that in. Complementary are 2 angles that add up to 90. So complementary, 2 angles that add up to 90 degrees. 2 angles that add up to 90 degrees. Right angles are not complementary. Can anybody take a stab at why they're not complementary? Because it's 1 angle. How many angles are needed to be complementary angles? 2. Okay? So right angles are literally 90 degrees. Complementary angles are two separate angles that add up to 90. Okay, so that's very good to know, because there will be trick questions that will try to make you name them. Okay, so first thing we're going to talk about, I want you to draw a slightly large C. Yep, there you go. So not a small c, you're going to be writing two things next to it. So complementary, hopefully you can see the green, complementary. Complementary angles look like a corner. So complementary angles look like a corner. So it's a way to remember it. Complementary corner, complementary corner. How many degrees are every single corner in the world? So this corner, that corner, the corner of the ceiling tiles, the corner of the room. How many degrees? 90. So complementary angles will add up to 90 like a corner. Okay? So this is the first example. This one is adjacent. So it's adjacent because it shares this wall. So that's the wall they share, or shared wall. So you want to write that the first set, this is complementary and adjacent. So complementary and adjacent. Because they do make a corner. So let's say angle 1 was 20 degrees. What would angle 2 be? 70. Why 70? Because that adds up to 90. Okay. So you could have adjacent and complementary, or you could have what we call non-adjacent. But they could still be complementary because all the complementary means is that they add up to 90 degrees. So you want to write that the second set, they're complementary but they're non-adjacent. So one of the angles could be 40. What would the other angle be? 50. Okay, they're still complementary even though they don't share a wall. Okay, because they add up to 90 degrees. At the bottom, you see this problem. It's not on your paper. We're just going to talk about it. You'll see name an angle complementary to 41, or you'll see name a complement. All right, so name an angle complementary to 41. So that means 41 plus another angle will make 90 degrees. So how do I find out what the other angle will be? Subtract from what? 90. Okay, so 90 minus 41 is 49 degrees. So 49 and 41, we call them complements. So complement. You've seen this word before. If you've ever stayed at a hotel, where do you see the word complement? Complimentary breakfast. Okay, complimentary drinks, complimentary bread at Olive Garden. Good stuff. So if you see name a complement, that just means two angles that are complementary. So you'll see that. All right. So we're going to talk about supplementary. If complementary are two angles that add to 90, supplementary are two angles that add up to 180. Good. So supplementary are two angles that add up to 180. So two angles that add up to 180. Two angles that add up to 180. Then you're going to draw a large S, just like you drew a large C. So top word will be supplementary. The bottom one, if you look at the picture on your page, the first picture looks something like that. Can anybody take a guess what complementaries look like? Yeah, straight lines. So I want you to write looks like, because it doesn't, so it looks like straight line, straight angle. Okay, they look like that. Okay, so it's a way to remember. How many degrees is a straight angle? 180. So if you remember supplementary straight angles are 180. Complementary corners are 90 degrees. It's a way to remember it. So this was your first picture. These would be considered adjacent. They're adjacent because, again, they share this wall between them. So they could look like this. So again, this is what makes them adjacent, because they share a wall. So let's say the first angle would be, we'll say this one is 100 degrees. What would the other angle be? 80. They could also be non-adjacent, which is the second picture you have. If the first picture was 70, or first angle was 70, what's the second angle? 110, because 70 plus 110 is 180. Okay? So our last example, name an angle supplementary to 41 degrees. So we want to find what angle adds up with 41 to make 180. So what would we do to find that? Subtract from 180. What is 180 minus 41? 139. Good. Good. So you would see supplement. Where have you seen the word supplement before? Like weight supplements, vitamins, things like that are supplements. When you get to college, you'll see a lot more. They're called supplement materials. Here's what that means. This book comes with the class, right? Okay. If I wanted something else, if I wanted you to read a book, this is math, so that's probably right. Let's give you another example. In economics, she has a textbook. Miss Hack has a textbook. But she also has them read a millionaire book, like a small, a book that you would read on your own. Does that make sense? So that extra book is called a supplement to the class because it's added on, it's extra. So you'll see the word supplement. It'll say name a supplement with 50 degrees. So the supplement would be 130 because what's 50 plus 130? 180. Okay? So we're going to do this last example together. Well, I could show you this. You'll see supplementary angles everywhere. This is a gate. Supplementary are two angles that make a straight line together. There are two angles that add up to 180. So these two angles that are highlighted, those are supplementary. These two angles are supplementary. Does everyone get the pattern? Okay, so they're everywhere. If you look on my wall, everyone see this straight line? How many degrees is a straight angle? 180. 180. So from here all the way to here is 180 degrees. This line comes straight up through my straight angle. So how many degrees is this angle? 90. How many degrees is this angle? What's 90 plus 90? 180. So a total of 180 degrees. That makes sense? So 90 and 90 are supplements of each other. All right, so we got one more thing to do on the back. We're going to be naming pairs of angles. If you name a pair, how many angles are you naming? 2 angles. So we're going to start with complementary. So you need to label them. I write comp. If you want to write complementary, you can. Complementary angles and then a colon so we can list them. You don't have to write a colon. It confused one of my classes earlier. That's how you list things or something like that. So we want complementary angles. What do complementary angles do? They add up to what? 90. They add up to 90. So we're looking for 2 angles that add up to 90. We are given 3 angles. So which angle can we automatically eliminate that will never add up to 90? 127. Yeah, definitely not this angle. So we need to check if 37 and 53, will they add up to 90? Yes. So they are complementary. We're going to name them. How can we name this angle over here? BAC. Sure. BAC. What else could we have named it? CAB. CAB. Could I have said angle A? No. No, why not? Yeah, it shares a vertex with another angle. So you'd have to use 3 letters. What are ways I could name this angle? RST. You could say RST. What else could you say? TSR. And then what's the last one? Angle S. So angle S because there's only one angle. Okay? So that is complementary. Supplementary, I always write sup, like this. So supplementary angles. Oop. What do supplementary angles do? Add up to 180. So we need to find which 2 angles will add up to 180. You can look at these two. You don't even have to do any math. If these two added up to 180, what would they form together? A straight line. Do they form a completely straight line? No. Okay, so those two won't. We already talked about 37 and 53. How many degrees did they make? 90. So the only other combination to try would be 127 and 53. And what do they add up to? 180. So they're what you're looking for. How do we name the 127 angle? Angle CAD, yep. And then how would we name, or DAC, same thing. We could also name, so 53 you could name angle S, or you can again name it RST, or TSR, or angle S. Good. The last one is adjacent. So this is the one you missed, Tony, and I'm very sorry. Do adjacent angles have any measurement relationship? No. What relationship did they have? They share a wall. That's all you're looking for. So you're looking for two angles that share a wall. They're next to each other. So what number angles share a wall? 37 and 127. Good. So we're going to name them. Let's name this bottom one first. So how do we name the 37-degree angle? Sure. BAC or CAB. Good. And then the second angle? DAC. Angle DAC. Or CAD, same thing. Good. You will have a section of this. This is not my favorite part to grade on the test because, as you can imagine, it's very detailed, right? But we're going to pause here and we're going to talk about our project. So you can go ahead and put that away.